We have Shelby. Shelby is a senior AI researcher at Salesforce. Her team has published 15 plus AI research papers, filed 10 plus AI patents, and released several competitive open source LLMs. Shelby, take it away. I will stop sharing,
Let me just get it up going.
and you're good.
Okay, awesome. Let me put it. Okay, good.
All good.
Perfect. Thank you all so much. Yeah, really excited to be here. Thank you for that intro. And you mentioned that we released several open source competitive models. That's exactly what I'm going to talk about today. So we recently just released what we call large action models. Now, we released our version 2 of these models only a couple weeks ago. So this is really new information and it's extremely competitive. And I'm really excited to tell you about what these large action models are, right? Because LLMs are pretty awesome. So, how are large action models a little bit different? And I'm going to show you how we've built them and how they're beating industry leading models. So, let's get started. A little bit about myself. Again, you heard from the introduction. I lead an AI research team at Salesforce. We're focused on developing the next AI that our customers and our products are going to need. And key focus areas for my team are AI agents, which is today's topic, but also related topics. Small language models is something I focus on device AI, on device agents. These are things that we think about. And we publish our research all the time and we open source a lot. Of course, a lot of things are going into product, but we're publishing, we're open sourcing even data. So everything I'm going to talk about today, completely open source, everyone. So I'm going to even give you links. You can check it out. You can try it out yourself. And of course, I'd love to connect with you all on any of this outside of this talk. Feel free to scan the QR code to connect. Awesome. So let's just get right into it. What are large action models? How do they work? So let's start with what we all know. We all know LLMs, right? You take a prompt, hey LLM, write me an email. You give it to the LLM writes a great email. We know LLMs very well at this point. But what's essential for agents is not just generating any text, it's generating actions, right? So if we look at this prompt here, it's different. This prompt is saying, what meetings are on my calendar this afternoon? Now, if we give that to an LLM, a typical LLM, without access to tools or anything, is not going to be able to answer this. To know what's on your calendar this afternoon, we'd have to access your calendar, right? LLMs, because LLMs are trained on historical data, they're not going to know exactly what's going on at every point of the day. And as you can imagine, there's a lot of prompts like this where a plain LLM would not be able to answer. However, if we empower that LLM with the ability to take action, allow the LLM to be able to navigate a calendar, to be able to navigate apps, to call databases, then we can do this. And that is the key for AI agents, right? So again, the key here is that we need to empower this LLM to take action. So what do we mean by taking action? An LLM still is generating text. So we're still talking about an LLM here, but how can it empower action? Well, it can generate completely executable text. So let me be specific there. So imagine that the LLM can generate formatted text that one specifies the tool or app that's needed. So it's very clear about that. So given that prompt, it selects the right tool or app. Two, not only selecting the tool or app, right? It needs to select the functions, the actions to take in that app to execute the prompt. So if we go back to our running example here, we have again, what are our meetings on my calendar this afternoon? We want to select the right app, which is the calendar app here. And we want to also select the right actions to take within an app. In a calendar app, there's a lot we can be doing, right? We can send events, we can cancel events, we can schedule things. Given this prompt, we want to select the right function to do in that app. This is a hard problem, everyone. This is pretty challenging because what we're asking an LLM to do is, given this prompt, select from all the possible apps, all the possible tools. There could be hundreds, thousands to choose from. So this LLM has to be really smart to do that. And we're also asking it to pick the right functions to do. So this requires a lot of intelligence to do this. So this is exactly what a large action model is, everyone. So it's an LLM that is optimized for taking action. So again, still generating text under the hood, but as you can see here on the right, it's generating a completely executable action. So this should be completely executable. It could be an API call. It could be a function call. So as we can see here, the correct app is specified. The function to take within that app is specified, as well as the variables needed to actually execute that function are completely specified, all based on the prompt. Now, again, our large action models are optimized for doing this. And another important feature about our large action models are their size. Okay, this is super important. As we think about more and more complex agentic tasks, there's going to be multiple steps, right? So the smaller the model, the faster each execution of that step is going to be. So if you can imagine here, if we look at this prompt, organize a team offsite for Q3. So much going on there, right? There's probably tons of steps that will be needed to actually to organize and execute that. So we could call the large action model to get each step right in the process and take the right actions. But if that large action model is also small, it's going to do each of those steps super fast. So we've got speed and we've got accuracy with our large action models. So I want to introduce to you all our open source family of large action models that we call XLAM. I'm going to give you the link at the end so you can check it out. It's all in Hugging Face. But these models, we've just released the second version only a couple weeks ago. So this is very new. We've released 5 models ranging from 1 billion parameters all the way up to 70 billion parameters. So that 1 billion parameter, if you look at other model sizes, I think I have a slide here showing this. That's 1 billion parameters is really, really small. So it's going to be super, super fast. And it's really competitive. So I'll show you that too. And so this new version that we just released a couple weeks ago is really good at handling multi-step tasks. That's the future of agents, right? It's not just performing simple tasks, it's multi-step. We've got that covered here. And most importantly, this is all great, right? We've got small models, we can handle complex things, but is it performing well, right? It's number one, everyone. Our models are number one on function calling leaderboards, beating industry leaders ranging from GPT-4o, Claude, and so on. So I'm going to get all into that. So again, one of the important features about our entire family that we release are the range of sizes. Now, these different range of sizes allow for diverse applications, right? The 1B model is going to be great. It's going to actually be able to fit on your phone. It's going to fit on regular phones. Now, the small models could be good for, performing this on your laptop. Maybe you just want a local model, tablets, and other devices. Then you've got the medium and large models. So let's take a look at the smallest family members. Yeah, and as I mentioned before, these are super tiny. So just to give you guys a comparison, if you look at this, we look at some of these well-known LLMs today. Look at how many parameters there are. DeepSeek, V3, 671 billion parameters. Mistral Large, GPT-3, Llama. These are big models. They're amazing models, right? Amazing models, but they're a lot of parameters. Our models, we've got a 1B, a 3B, right? And a 8B model. So super small in comparison, which means less resource consumption. It's going to be super fast. Yeah, so as I mentioning, so many benefits to these small models. Good performance, I'm going to show you that on our leaderboard. Fast, cost efficient, sustainable, of course, trusted, and we can deploy it anywhere. That's really the key. So if we imagine being able to take one of these smaller models, maybe that 1B model, and putting it on a phone, here's how it could work. So you could take that. So you imagine you have the prompt about scheduling on your phone. That prompt will be passed to the 1B model, and the 1B model would select the correct tool, would write the right function call. Then the backend of your app or your phone would be able to execute that action, so actually making that API call. And then XLAM would generate the final response, as you can see here, which is you have a meeting tomorrow at 3 p.m. So this is an example of how you could leverage XLAM in a workflow on your phone, but of course, similar things, on any of your devices or on cloud. This is how you could leverage XLAM. Now, as I've mentioned, we also have the medium and large members, but let's get right to showing where they all stand on this leaderboard. So, if you check the Berkeley function calling leaderboard, so this is one of the most important leaderboards out there. It ranks models on simple agentic tasks or simple function calling tasks, all the way to multi-turn, multi-step tasks. And so what you can see here is that our models, our 70B model, our 32B model, are number 1 and 2 on the Berkeley function calling leaderboard, beating if you check that leaderboard, you can see in in this screen clip, beating GPT-4o, beating plenty of other industry models. And most impressively, if we look at our 8B model, so only 8 billion parameters, that's a really small model, beating GPT-4o on these tasks. Now, where did our other small models place? They still place pretty impressively for their size. So again, a 3B model, only 3 billion parameters is still ranking quite up there, beating a lot of industry leaders on these tasks. And finally, our 1B model. Again, still pretty competitive for being only 1 billion parameters, one of the smallest models on this leaderboard. So, yeah, so how did we achieve this? So the key, everyone, the key is all comes down to the data. That's really the key here. As I mentioned, these large action models are still LLMs under the hood. So what we did is we took base LLMs. We had some pre-trained model. We started with some open source pre-trained models. That's nothing super special, right? What was special is we generated very carefully what we call action data or trajectory data. So if you look here on the right, this is an illustration of what one data point of an action trajectory looks like. So what we did, if we look here on the right, we see a task. So here, for example, the task is, what is the phone number and email of my friend Astro? And what we see below are the correct actions to take to complete that task. So the correct actions here would be to navigate contacts and get the phone number of Astro. So this would be the actual API call. The second step to take would be to actually navigate contacts again and get the email of Astro. So this is just one single data point. We generated thousands of data points like this. And so imagine if you have thousands of data points like this, you train your model on that, your model is going to be really good at generating actions and executing complex tasks. That's exactly what we did. So as I mentioned, I'll have a link in the next slide. We have released a lot of ideas on how we did this. As you can imagine, looking at that trajectory data, you can't just find that anywhere, right? That's not common going back to that trajectory data. This is not common everyday data, right? If we look for data, there's plenty of open source data sets that we've seen in the past, but this is a newer emerging type of data and so we've released multiple publications on how we've synthetically generated this. So I encourage you to check this out to get some ideas there to understand how we did it. We've also, like, as I mentioned, open sourced the model and also part of the data. So with that, hopefully that gave you a little preview of XLAM. Check out XLAM on Hugging Face. You can check out even some of the data. The papers will be linked there as well, so you can see how we've generated that data. And we also started a new YouTube series that I'd love for you to check out too. Thank you all so much.
Shelby, one or two questions. So,
Yeah.
is this in production to power some of the AI agents at Salesforce?
No, it is not in production yet. Right now it's at the research phase, but yeah, we hope that in the future it could be deployed.
Okay, that's the idea. Where do you think this is going after? This is obviously very impressive. I love the domain specific of it, and it just builds upon the whole specific AI agent and powered by domain specific models. Like, where do you think
Hmm.
this is going next?
Yeah, I think you know, continuing to broaden the data set, that's one of the challenges. I think data is a challenge for getting AI to, perform in different domains. So, thinking about increasingly complex trajectories, how do we generate those? How do we make sure they're correct? That's generating new processes for that. I think that's going to be important. Um, and again, doubling down even on model size and model efficiency. I think what we're seeing today is latency, is becoming more and more important for agents. I think in the past year we've been focusing on just getting an agent to work, right? But now the industry, we're starting to get agents to work. Now we need to speed them up. And so I think getting doubling down on these large action models or whatever you're using for your agent, thinking about small models powering as many steps as you can to improve latency is going to be key too.